Example number 2, review of conics. First thing I want to look at the general conic equation is to notice that there is only the x squared term, making this conic a parabola. Again, we're going to complete the square only for the x squared term. So let's go ahead and group that together, the x's together. Now everything else, let's go ahead and move to the other side, negative 2y and minus 7. I'm going to go ahead and complete the square. There's no coefficient in front of the x squared term. So x squared minus 6x plus negative 6 divided by 2 squared, again part of the process for completing the square, equal negative 2y minus 7. Completing the square, these three terms will collapse to x minus 3 squared. Actually, I forgot to mention, I added this to this side of the equal sign, maintain equality, make sure that you also add this to this side. Okay, so now back to over here, I had x minus 3 squared. Now here, combine like terms, I have negative 2y. Now using my calculator, I perform these two calculations, I get positive 2. Last step for standard form is going to be to factor out the coefficient in front of this term out here. So negative 2y minus 1, because negative 2 times negative 1 has to yield that positive 2. Now, this right here is in standard form for the parabola. Now, recall that standard form, in front here, I had that this was equal to 4p. So let's go ahead and say 4p equal to negative 2. Let's divide by 4, so that we get that p is going to equal 1/2. It's going to be useful when we start sketching this right now. Again, let's create our grid. We're going to leave the standard form up here. Again, the only difference here, as opposed to ellipses and hyperbolas, is that you don't have a center point. You actually start off from the vertex point. So, vertex point, go to the x opposite of this. Wherever the x is, you have a negative 3, so I have positive 3. Go to the y opposite here, I have a negative, I have a negative 1, opposite would be positive 1. So I would sketch this. Now, I know that this p-value of negative 1/2 is how many units I'm going to have to travel along from the vertex. So I'm going to change my coordinate to, instead of going by ones, every other two I'm going to go by ones. So I'll make this 1, 2, 3. Same thing over here. 1, 2, 3. And that way I'm going to go ahead and plot my vertex point. Again, not the center point. It's slightly different from what we were previously doing with, or what we were doing with ellipses and hyperbolas. So I have my vertex point, and again, next thing to notice is my p-value. P-value is negative 1/2. So from the vertex, since it's negative 1/2, I have to travel that negative half unit down, and I'm going to go ahead and plot the focus point. Actually, it is all the way over here because of my scale. Now, again here, you know that your parabola has to open downward because the focus has to lie inside the parabola. If I go half a unit in the opposite direction, what I get is the directrix line. So let's label this directrix line. Again, and just based on the geometry of this sketch, let's go ahead and get the information. I have the vertex. The coordinates of this is going to be, I had mentioned already, I had put over here 3, 1. The focus, now if I'm at 3, 1 and I moved half a unit, coordinates are going to be 3, 1/2. And finally the directrix line is going to be y equal, since it's horizontal, and you can see here that you are at the 1.5, so y equal 1.5. You want to change this to fraction, you can say y equal 3/2. Okay, and there you have the sketch and the pertinent information, vertex, focus, and the directrix line.